So today we are going to talk about how are we going to predict, like for example, in this case, okay, I use the example in the discussion. Okay, so we don't know what is the percentage of people who are left-handed, okay? So because left-handed and right-handed, so you see, these are not numerical value. Am I right? So anything that is not numerical value, we have to put it to numerical value so that we can calculate the probability, or we can calculate the mean and the standard deviation and so on. Am I right? Okay. So I use logic 1 to represent a person who is left-handed, and logic 0. So you see, this is like a Bernoulli distribution. Am I right? So this is the probability. Okay, so the probability for this one is P. Yes. So may I know what is the probability of not left-handed? 1 minus P. So can you find the mean for this one? Can you find the mean? Still remember how to find the mean? Forgotten, give back to Miss Do. Miss Do, you are going to overload of information now. Because all of you give it back to me, ma. Am I right? So this will be equal to 1 times P plus 0 times 1 minus P. So we got it as P. Yep. So how about the standard deviation? It will be square root of sum of xi squared pi minus the mean square. Am I right? So this will be equal to square root of 1 square times P plus 0 square times 1 minus P. Take away, the mean is P. Am I right? Okay. So this will give us square root of P minus P squared. So this will be square root of P 1 minus P. Okay. Yeah. And we know that our population distribution is definitely not normally distributed. For example, this is a situation. This may be the situation. And this is P, and this is the other one will be 1 minus P. Which one is taller? Which one is higher? We don't know because we don't know the value of P. Yep. Hello? Are you clear? Okay. Can or not? Okay, so now we don't know the true population proportion of people who are left-handed. So we take the samples. So according to central limit theorem, how should we choose the sample size? So that our sample mean is normally distributed. Our sample proportion, okay, correct me, sample proportion should be normally distributed. So the criteria is N times P must be greater than 5, and n times 1 minus p must be greater than 5. Okay, I give you an example. So example here, someone claimed that the proportion of people who are left-handed is 12%. Okay, proportion always must state in percentage. Please bear in mind. So now, before I start to choose the sample, okay, and find the proportion, so I have to justify, see whether my sample size is large enough or not. I use the proportion in this claim. So now, my P here is 0.12. So now I substitute into here. So I get the N here. So can you find the N here? Find for both sides. So can I have the answer for this part? I touched my calculator. Okay, it must be greater than 41.67. And this one you don't have to say. Okay, 5.68. So look, okay, so it's very important if you have the N, it means that it must be the part whereby it overlap. Are you clear? When you have the word N. So my situation here will be like that. Let me draw a number line to show you. So here is my 41.67. So it must be here onward. And the other one is 5 point something. You learn this in your high secondary school, correct? So the overlap part is here. So I will write there, minimum sample size is 42. So that sample proportion distribution will be normally distributed. Okay, so this is always the criteria that you have to check whether the sample size is large enough or not. Are you clear? Whether the sample size is large enough or not. So now, according to Gina, is her sample size large enough? Yes, because he used 100. Am I right? Okay. So according to CLT, the first one is determine whether the sample size is large enough or not. Because we know that proportion variable definitely is not normally distributed. Okay, so it's also according to CLT. According to CLT. So sample proportions, how is the symbol look like? Okay, the symbol look like this, a P and let it wear a hat. So this is called sample proportions. Are you clear? And how do you get the answer? Okay, afterward, I will teach you how to get. So according to CLT, what is the mean of the normal distribution for this sample proportion? Can you tell me? Hello. Is equal to the population mean, am I right? Then it's equal to P. And what is the standard deviation of this sample proportion distribution? It will be equal to the population standard deviation divided by square root of n, am I right? So, and from here, we know that this is the population proportion, am I right? Hello? Am I right? So, I substitute into here. So both also got square root, correct? So how will I write it? Yeah, so can I move on? So now we want to go to our confidence interval for true population proportion. How to predict? So now, can I move? Okay, next, our task will be how to predict the true population proportions. And this one I write in blue means specific case of people who are left-handed. Okay, so our point estimator is a sample proportion. And in this case, our sample proportion that we use will be equal to, we always put X over N. X is the number of people who are left-handed out of 100 people. That is called your X. So in this case, it is 15. The number of people who are left-handed out of. So in this case, it's 15, and our N is equal to 100. Are you clear? So our proportion will be 15 divided by 100. So this is 0.15. So this is our point estimator. So we are going to use, 95% confidence level. So still remember what is the corresponding Z-score for 95%? So now if I draw this proportion, sample proportion distribution, it will be normally distributed. So our point estimator, the p hat, will be the middle, and this is equal to 0.15. Am I right? So we have our highest, lowest, and our highest. And we have our corresponding Z-score. Am I right? Standard score. So what is our corresponding standard score? If our confidence level is 95, everyone should be very familiar. Negative 1.95. Is it 1.95? 96. And highest is 1.96, correct? If it is 95, or we always call it Z alpha over 2, okay? Yep. So if you are using the formula, then the formula of predicted, okay, you go and derive it by yourself, or I should derive for you. Hello, can you answer me? Should I derive for you? I should derive for you. Okay, I derive for you. So can I move to the next page? Not yet. Okay, not yet. Okay, done? Okay, okay. Okay, I wait for you. So we have to use this formula. The relationship between Z and X, correct? Still remember this? Hello. All of your memory very poor. So for the lowest predicted, this is the lowest predicted. I find lowest. Take away, what is the mean? P hat. Never mind lah, we general first, okay? Over How is the standard deviation look like? Square root of correct? Then that is our negative Z alpha over 2. Am I right? So the lowest predicted will be you cross multiply, correct? So can I say that is P hat minus Z alpha over 2 times by square root of P hat 1 minus P hat over N. You just bring this one over and bring this one over. Got it? Am I right? Hey, these are simple mathematical calculation. I don't have to show step by step, correct? So can you do the highest also? By yourself now? Okay, so the highest is positive Z alpha over 2 equal to the highest minus P hat. The standard deviation is square root of P hat 1 minus P hat over N. Okay, so this one cross multiply and this whole thing bring over, right? So your highest predicted is equal to P hat plus Z alpha over 2 square root of P hat 1 minus P hat over N. Yep. Okay. So therefore, the population proportion predicted, the lowest is the point estimator, take away Z alpha over 2 square root of P hat 1 minus P hat over N. And the highest is point estimator P hat, take away Z alpha plus Z alpha over 2 square root of P hat 1 minus P hat over N. Clear? Okay, so now for our case here, our P hat is X over N and our X is 15 and the N is 100. So it's equal to 0.15. So can you please put into this formula, and our confidence level is 95%, which means that the Z alpha over 2 is 1.96. Okay, you try to count, see whether you can get the answer or not. Hello, take out your calculator and count. Substitute in P hat at 0.15. Always, you substitute into the formula, it must be a decimal. What do you get? What do you get? 0.0. 0.0800. This one? Highest? 0.2199. So 2199. Okay, so look, be very careful when you write. So look here how we write. We are 95% confident, that the true proportion of people who are left-handed. I'm trying to write as small as possible. Okay, can be as low as, remember, must write in, I better write in rate, percentage. And as high as 22.0%. If you fail to put in percentage, for this case, I will give you 0 mark for that. How am I going to get it on? 2199.85. 0.220 can already. Three significant figure. Okay, you get me? So that is using formula. Okay, now, so is the claim just now we have justified? Is the claim just now we have justified? What is our claim? I said 12%. Is 12% lie within the confidence interval? Yes. So I said this evidence support the claim because 12% is less than 22%, but greater than 8%. So this evidence support the claim. So we have insufficient evidence to reject the claim. Are you okay? So that is using formula. So do you think that we can do this without using formula? The answer is definitely a yes. So can you please find out a way to do it by yourself now? So GC, so GC is very useful. GC. Okay, so when we use GC, we search for, we go to test. Where to find test? We go to stack. Then we go to test. It shouldn't be a button, so don't draw button. Then after that, you select one prop, Z interval. All right? And if you select that, you obviously know you are at the right track because how many number you are supposed to key in? Very simple, 2 number. Sorry. Okay, confidence level 0.95. And you got the answer come out. Then you put it into words. You interpret it, correct? Then you justify the claim. So, I repeat the whole thing. So when you write your folio, you also have to write it in this way. how you can get the formula, how you get the right sample size. Are you clear? Okay. I'm trying to kill two birds with one stone, okay? So that I can cut down briefing on how to write the folio. I'm briefing you now. Okay, can I? Okay, so first of all, we know that when you talk about proportion, it's definitely not a numerical value. So we give that kind of logic, 1 and so on and so forth. Am I right? So then we find the mean of the population and we find the standard deviation of the population according to what we have learned. Okay. So this is the first thing that you have to explain if you are writing something about proportion. And for your folio, we hope you can write both prediction of mean and prediction of proportion, population proportion. You try to have a scenario whereby you can talk about both. Yeah, that will be a better report. Okay, so that one we will talk about it in 2 weeks' time. Yeah, so proportion, got it? So you have to explain all like that. So theoretical part. So after that, you say that since the population is not normally distributed, so definitely we must choose a suitable sample size. So according to central limit theorem and according to our syllabus, we are going to fix it at your NP and your N1 minus P must be greater than 5. So that is the first judgment of suitable sample size. Yeah. So you give an example, you give a claim based on the value of the claim, you choose a suitable sample size. That means your sample size minimum must be, in this case, is 42. So if the minimum sample size is 42, so that the sample proportion distribution is normally distributed. So should I take 100? Should I take 200? No, I take 100 is, I think is much, much bigger already. Am I right? So I don't have to waste my time and waste my money to take a sample of sample size 200. Are you clear? If what with the sample size of 50 or with the sample size of 100 can give me the same result, why should I waste time on bigger sample size? Are you going, is it going to give us more precise prediction? That one you will discuss later in your folio. We will talk about it step by step later on. Are you clear? So this is what you say. Then after that, okay, we talk about how the sample proportion distribution look like. It's normally distributed. We state down the mean and we state down the standard deviation. After this, we show to the one who read the report, how are we going to derive the formula? That is how we derive the formula. With this and with this. Then we count. Yeah, we use the formula to count. Then after that, we also describe how we use technology to help us to solve this problem. Then we justify our claim. So that will be the theoretical part of proportion. So theoretical part of population mean also go in this manner. Hello? So for the mean, later I will brief you again when we write our folio. So when you write your folio, your theoretical part is about 2 pages only. The rest will be justification of the claim and how you play around with it. You're supposed to write maximum 15 pages. You headache?